Hello students, today we are going to start with exercise 6.5, that is part 4 from this triangle chapter. That is the last questions we are going to do it, and very important question. Coming to question number 15 students, a diagram is not given. We have interpreted it. In an equilateral triangle ABC, D is a point on BC such that BD equal to 1 upon 3 BC. Prove that 9AD square equal to 7AB square. So as the diagram says, here we all know that here it is given that it's an ABCD. ABC is an equilateral triangle. So ABC is an equilateral triangle. So ABC is drawn. D is a point. D we can find it is a point on BC such that BD is one third of BC. One third of BC, right? Prove that 9AD square equal to 7AB square. So one third is less than half. So D is a point here which is still little closer to B we have drawn. So it is an equilateral triangle and we know that BD is one third of BC and we have to prove this fact. 9AD square equal to 7AB square. Now here square is there. So obviously we understand that yes we have to use Pythagoras theorem. But we can't apply here because we cannot find any right angle. So to find the right angle, to apply the Pythagoras theorem and solve this, so we require here construction. So let's do the construction here. So for the construction, here let's draw perpendicular from the point A to the BC. So once the perpendicular is drawn, then we can apply Pythagoras theorem. So here construction is needed students. So here we select perpendicular, we are drawing it. Okay. So perpendicular is drawn. Let us take this point as E. So AE is perpendicular to BC. This is the construction. So when you have to write, so here we can write given that triangle ABC is an equilateral triangle, and we all know that equilateral triangle means all the sides are equal. Equilateral triangle. So AB will be equal to AC will be equal to BC. Let us assume that is side A. So that becomes a little easy. So here we assumed A, A, A. So when you assume this A, does it make some difference what we have to prove? Here we have to prove that 9AD square equal to 7AB square. Now AB is A. So if you assume ABA, so here we have to prove 7A square. It can be if you prove 7BAC square, then also it is proved because all the sides are equal to A. BC square is also A. So we have to bring RHS in terms of A. We have come to know. Can we use some other properties of equilateral triangle? We could think about that. Here we have drawn this construction. Okay. So we have wrote about the sides. Let's see what we have to prove. So we have to prove here students that 9AD square equals to 7AB square. So this is same as we have to prove 9AD square equal to 7A square because we have written the form of A. Now when we write for the proof, here we know that students, here construction we have missed out. So let's write the construction. So construction is draw AE perpendicular. So we are drawing AE perpendicular to BC. So here we know that AE is perpendicular to BC. So A is the altitude. But this triangle is an equilateral triangle. So altitude, median are one and the same. So here we need to mention that in triangle ABC, here we can say AE is the altitude as well as median. This is true only for an equilateral triangle. So AE is altitude as well as median. So we come to know this. So if you know this fact, A is altitude as well as median, so I can apply Pythagoras theorem. I can also say if it is a median, so BE and EC, therefore we can also say that BE and EC will be equal to half of BC, that is A upon 2. BC is A, so A upon 2. So we are just trying to find all the facts. Now like the previous sum, here to prove this, we have considered LHS and you proved RHS. The same method, we will consider AD square. We will find what is AD square, which triangle will get AD square, and we will try to manipulate RHS such that we get A. So AD exists in only one right angle triangle, that is AED. So let's do in right angle triangle AED. So if you are considering right angle triangle AED, we all know students AD square equals to AE square plus DE square, that is by Pythagoras theorem. Once we applied that, now we have to check we require in RHS everything in terms of A. AE is cannot AE is not in terms of A. So can I write AE in terms of A? Yes, either by considering triangle AEC. So I can use Pythagoras theorem in triangle AEC, or I can use even in triangle AEB. Both are one and the same. Any of the triangle you can choose. So I'll just write here point number 1, here point 2 and point 3. We are just considering right angle triangle. In case suppose if I consider triangle AEC, I'm just saying you can take AEB also. So we will just try to replace AE such that we get A. Now you will say, what about DE? DE is a part of BC. So definitely I can replace the DE in terms of A. So let's first bother to do it, replace A with A. So here if I consider triangle AC, I know that AC square will be equal to AE square plus EC square. Correct? What is AC square? A square. And A square we need to replace that plus, and EC is nothing but half of BC, that is A upon 2 the whole square. So students, here we can write, therefore this term will go this side. So we'll get here, I'll just continue down only. Okay. So here we will get A square equals to, that is 4. So we can find A square will be equal to this A upon 2 the whole square will go this way. So A square minus A square upon 4. So here when we take LCM, here 1. So here 4A square minus A square upon 4. So we'll get 3A square upon 4. So A upon 2 the whole square. So we got AE in terms of AE square we have got, that is 3A square upon 4. Correct? Once we got this here, that is A square, here we have got. Can we substitute this? So we got the value of AE square. So we can substitute this. So we got AE square and we know what is DE. Correct? So here we can get, we'll substitute this. So we get AD square equals to, here we have 3A square upon 4 plus. Now we want DE square should also be written in terms of A. Let's try to find out how can we write DE in terms of A. So here we can see, students, that DE is actually a part of BE. DE is a part of BE. We know that BE is half of BC and BD is 1/3 of BC. See, can you see this 1/3 of BC? Because here it is already given. I think I forgot to write it. So I'll just jot down here. You also know that BD is 1/3 of BC. So here we can write BD is A upon 3. So can I find DE? So we'll just continue here. So this is a 4th step, 5th step. So we can just continue here saying that here 6th step. Here I'll write BE is nothing but BD plus DE. So our aim is to find that DE should be written in terms of A. BE is what? A upon 2. Correct? And we know that BD is also A upon 3. Can you see? BD is A upon 3 which is given, and BE is half of BC plus DE. So can I find DE? I'll take this A upon 3 this side. So I'll get A upon 2 minus A upon 3 equals to DE. Can I cross multiply? If I cross multiply, 2 3s are 6. So you'll get 3A minus 2A equal to DE. Therefore, here we can find out DE is nothing but A upon 6. Once we get the value of DE as A upon 6, can we substitute here and get it? So here we can find AD square equals to, so 5th one we can substitute, sorry, this is 7th one. So we can say AD square equals to 3A square upon 4, and here instead of DE square, sorry, this is DE. So here we can write A upon 6 the whole square. This you can say from 5 and 6. So let's solve further. So we'll get AD square equals to 3A square upon 4 plus A square upon 36. So what is the LCM here, students? Here the LCM is 36. So 4 9s are 36. So here we'll get 27A square. Here also to multiply by 9, right? Plus A square. So here we'll get 27A square plus A square is 28A square upon 36. Therefore, AD square equals to 28A square upon 36. I think this can be reduced by 4 table. So 4 7s are 28. So we can just write 4 7s are 4 9s are, students. So 7A square upon 9. This 9 when it goes aside here, when this 9 goes aside here, this will become 9 step, that is 9AD square equals to 7A square. So this will get 9AD square. A square can be replaced with 7AB square. So thus we proved by using Pythagoras theorem that 9AD square equal to 7AB square. I hope this is very clear for you. Here we are just using the fact of property of equilateral triangle and the fact that AD, the altitude and the median are the same, and we are using Pythagoras theorem. So considering the LHS, we took the first right angle triangle and tried to manipulate the RHS, that everything in terms of A. And when you do it, so first I placed A square such that I get A in terms of A. So I got AD square equal to 3A square upon 4 plus D square. Then DE is also we have to replace in terms of A. So D is a part of BE. So using that D, we got A upon 6. By substituting and reducing, simplifying, we got this. Okay. Moving to the last sum of this triangle chapter, that is exercise 6.5, 16th sum. We'll do this. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of one of its altitude. As you find, the 16th one is also related to equilateral triangle. So I'll just draw now. Here equilateral triangle, here we find, so I have taken equilateral triangle ABC. Let's assume ABC equilateral triangle. We have to prove that 3 times the square of any one side. So again, equilateral triangle means just assume this letter so it becomes easy. So here it is said that 3 times means into square of any one side, that is A square. So 3 into A square is equal to 4 times the square of the altitude. So we require altitude. So we can just take the scale and we can draw the altitude here. So I move here. So we get the altitude. Okay. Yes. So altitude is ready. Let's take us this. So we have to prove here, basically we have to prove that here 3 times means 3 into A square is equal to 4 times the square of the altitude, that is AD square. I hope this is very clear. Here given, we can write again, triangle ABC is an equilateral triangle. It is an equilateral triangle, and again we know that equilateral triangle means all sides equal. Equilateral triangle, and that means we can say AB equals to BC equals to AC equal to A. We have taken the construction, sorry, this is BC equals to AB equals to BC equals to AC, this is okay, and this is equal to A. So here now we will have construction. We have taken construction, we have drawn AD perpendicular because we require altitude, AD perpendicular to BC. Now once perpendicular is there, you have understood that we have used Pythagoras theorem. Again the property of equilateral triangle we are using, that this AD since triangle, here we can say since triangle ABC is an equilateral triangle, it is an equilateral triangle. So what is AD? AD is the altitude and also the median. Therefore we can say AD is altitude as well as median. So if it is a median, again it will bisect the opposite side, correct? As well as median. So if you apply that property of median, students, we know that BD and DC is half of BC. Therefore, we can say BD equals to DC equals to half of BC. That is nothing but A upon 2. Correct? So this is BD is A upon 2. So can we apply Pythagoras theorem? Now we want LHS as 3A square. So either you can consider right angle triangle ADB or ADC. Doesn't make a difference. So here we'll consider in right angle triangle ADB. So we consider right angle triangle ADB. We are applying Pythagoras theorem. So when we apply Pythagoras theorem, we get AB square equals to AD square plus BD square. So what is AB square? Here it is A square. We want AD because see we want RHS AD square. So can I write BD in terms of A? Yes, it is A upon 2 the whole square. So please put the bracket, don't forget. So I'll get A square equals to AD square here plus A square upon 4. I want AD square in RHS. So can I take this A square upon 4 on this side? Yes. So what you will get here? A square minus A square upon 4 equal to AD square. Can I cross multiply here? So what do I get? 4a square minus a square upon 4 equal to ad square. So 4a square minus a square will give you 3a square upon 4 equal to ad square. So here we have this 4 will go here. So I think we have reached the step where we have proved that 3 times the square of the side equal to 4 times the altitude. This can be written as 3 into ab square or anything this side equal to 4ad square. So I hope you have understood this sum very easily. We are just using the property of equilateral triangle and we are bothered to find out what is an LHS. We find LHS and prove that it is equal to RHS by manipulating. I hope you have understood, students. Thank you. Thank you for watching.